Hello friends, welcome to Python in Shorts. Today we will be looking at and ampersand operator in Python, the difference between these two operators, or rather I would say understanding both of them separately, and also we'll explore some of the topics like Boolean types, truthy and falsy values, short circuiting or lazy evaluation, class truthiness, and lastly data frame logical operations. To start with, and one of and is one of the logical operator which performs logical operations, that is to decide course of action, or simply putting, to check conditions. uh, like for example, if this video is informative and you like this video, then you will hit subscribe. uh, I hope you will do it. uh, so basically, if both of your expression stands true, then it will be evaluated to true, or else it would give you false. So let's see how it works in Python. Let's take a variable equal to 5. Now if is greater than 3 is less than 3, then we'll print one statement. A lies between 3 and 10, and now we'll execute this statement. So this gives us the statement A lies between 3 and 10. So basically what is happening here is, first we are checking if A is greater than 3 and A is less than 10. So expression 1 is evaluating to true, as A is actually greater than 3, and expression 2 is also evaluating to true, as it is less than 10. So our statement got executed, like print A lies between 3 and 10, right? So now this takes us to another stuff in Python called as truthy and falsy values. Truthy values are the values which themselves are not of bool type, but they will evaluate to true or false when used under certain conditions. For example, let's take this if statement. Here my expression 1 and expression 2 both are evaluating to true, and hence our print statement is getting executed. But what happens if I write my if statement like this? Print. Now here still this statement is getting executed even though I am not comparing A with anyone, or I am not using any expression. Still this is evaluating to true. So this is what truthy values are. Means if we see the type of A is not of bool type, it will be int, but still it is evaluating to true when used under certain conditions. Like here we are using it with if, or we can also use it with like while conditions in a loop. So now we will see from where this evaluation is coming from, like why A is considered as truthy value now, sorry, false values. So now let's look at dunder method of A. So here we have something called as bool, and if we try to execute it, we get it true. That means A will always be evaluated as true, and hence it is considered as a truthy value. Let's take another example and create a variable B and B dot. If we try to execute it, we get a false. That means B will always be evaluated as a false, and hence it is considered as a falsy values. So the values which are not falsy values are considered as truthy values, like empty string, list, empty set, 0, 0.0, or likewise these all will be considered as falsy values. Empty set or list or tuple. So these were the truthy and falsy values. Now these AND operators are lazy evaluators, or we also say it like the short circuit evaluation. Let's understand this. 5 and 90, 900 and minus 1. Now this is where lazy evaluation comes into picture. Here AND is restricting Python to evaluate further lines or statements if it has already got the results. For example, 21 is Truthy value, so it must check other statement that is 2, which is also true. Hence it outputs as 2 as it was the last executed statement. One note here we will not get output as true, but the result will be evaluated as true. Same with the other example as well. 465 is a true value, so Python must execute next value to check if it is true or not. So it checks for 890 and it is also untrue. So 890 was the last executed statement, so we get output as 890. Similar with this example as well, but when it comes to 0 and 31, Python stops when it evaluates 0. Why this happens? Now here 0 is a falsy value. That means it is of no use as output will be evaluated as false. As for and both expression has to be true. Hence evaluation stops at 0 and output is given as 0. This is what lazy or short circuit evaluation is for operators. Whereas for ampersand the case is totally opposite. It works on eager evaluation. That is, it won't stop until whole line or statement is executed. Let's just first understand ampersand operator, how it works. So let's start with example. Okay, this gives me false, and this also gives me false. That means ampersand operator is also doing some kind of logical operations, but when it comes to values, we'll see how it acts. So here we are getting output as 3. Now we need to understand why it is 3. So basically ampersand is just performing a logical operation, but on top of it, it performs a bitwise logical operation. That means it will convert this decimal values to binary value, and then it will perform the logical operation on the bits of those binary values. I'll just explain this. Let's take this example of 11. 23 gives me this value. Now if I take this value here, 1 0 1 1 1, so now make sure that here we don't have to add these values, rather we have to perform a logical operation and operation on a bitwise. So 1 and 1 will give me 1, that is true. Again true and true. 1 and 1 will give me 1, that is true. Again 0 and 1 will give me false because one of it is 0, so it will be 0. Same will go here, 0 and 0. So finally we are getting value as 00011. Now we'll see what this comes as. So here we can use int function because it has a secondary argument where we can give the base, and so it will convert the binary to decimal. So here this value will be like this. Okay, so now we are getting here as 3. That means ampersand is also performing logical operation, but it performs the bitwise operation on the binary values of the decimal values which we have provided. So this is what ampersand value does, operator does. One thing to note here is that unlike AND, ampersand is not following lazy evaluation. That is, in order to produce result, Python must evaluate both the values no matter what the value is present in right hand side. This is called eager evaluation, that is opposite of lazy evaluation. We'll check this in more detail when we will be discussing data frame logical operation. Before that, I wanted to talk about the Truthy values of class object. By default, if we prepare a class, let's just prepare one class and if I prepare one more method like get name, which will just return the name that we are passing. Okay, so this is our class. Now we'll check the truthiness of this class. That is, first we have to prepare the object stu student with name. Let's take my name and stu empty name. This is our another object. Student and true. Now this object is evaluating to true, right? Because we have passed some name. But let's see what happens to this object. Let's just copy this. Now this is also evaluating to true. Even if I am passing empty student name. Now we can modify or override the truthiness of class by using bool under method. Let's see how we can do this. We can just add one more method to send return name greater than 0. Now we have just prepared this class, and we'll try to make this object again. Now this object is evaluating to true. Let's see what happens to this object. Now this is not evaluating to true. That means this is evaluating to false. So this is how we can change or we can manipulate the truthiness of the class object. Okay, now let's get into data frame logical operations. One thing to observe in case of data frame is while comparing the condition, we are using ampersand with parenthesis. Instead of using AND operator, we use ampersand operator. Let's have a look on it. So let's just create a data frame. And now we'll try to compare this column. Now here AND is failing, stating truth value is ambiguous, that is, it just does not work on Boolean arrays. Okay, to understand this, let's explore Boolean array and broadcasting in Python. So for that, let's prepare one series. So here is our series, and now we'll just apply some operation on it. So here the output which we are getting is an Boolean array, and the operation which we performed is broadcasting. So basically broadcasting is applying an operation on each value of series like this. Let's take another example. Prepare one list. Is equal to array. Now let's just perform some operations on it. And let's just print it. So here we can see, now for numpy, when we multiplied it by 2, it was applied on each value. This is what broadcasting is. But for list, it was just applied on whole list and it replicated those values in single list. Here as well, ampersand operator is overloaded for series and numpy object so that it can work with broadcasting or boolean arrays like it did here, in which we got the output as 2468. So for numpy and series, basically data frames, some operators are overloaded and perform differently, unlike in base Python. For example, star, this multiplication operator, and this greater than operator, and along with this there is an ampersand operator. Here ampersand operator is overloaded to perform operations on each value of series, very similar to how it performs on bits of binary value, and the main thing is it returns series. So to understand this, let's take another example. Here we'll change it to A2. Here A1 and A2. Here A1 and A2 will again give the same error which we got earlier, but A1 and A1 ampersand A2 should return a boolean array. So this states that the return value of the ampersand operator in case of series or numpy object is an boolean array. This is why we use ampersand in case of data frame when comparing the values. Let's see how we do it. So this is our data frame. Let's create mask, that is dff of num less than 3. Greater than 5. Wait, we wanted means the output should be 1 or 1 and 2, but here we are getting an empty data frame. Okay, so the answer lies in operator precedence. Now this is very important, friends. Whenever we are working with boolean array, we always have to take care of operator precedence, that is Bodmer's rule. Here if we enclosed our conditions in parentheses, then the operator precedence will come into picture and we may get the right results. Let's see how we can do it. Yeah, now we are getting this 1 and 2 value. So this we have to take care of. Whenever we are dealing with the boolean arrays, we have to consider this operator precedence as well. That's why we are using OR operator or ampersand operator with brackets when dealing with data frames. So this was all about the data frame logical operations, and with this we will close this discussion here. Please mention in comments if I have messed up somewhere or if I missed something. Keep following for more such in shorts. Thank you.